Now should be switching on the microphone helps. Well, great that we realize all of this just as we're getting started with new content. Great. So multiple views. Why do we want multiple views? Well, there is this eyes of a memory principle, right? Where we have, like it's sometimes easier for us to see multiple things next to each other than to memorize and switch to a different view. So if we have multiple views, we can see things at the same time in the same space, and then can kind of like bring together this information mentally. And so we have this trade-off of display space and working memory. And when we have multiple views, we often also talk about linked views. So multiple linked views are views that are simultaneously visible and linked together, such that actions in one view affect the other. So for example, if I have a dashboard about cars, I can click a car in one view and I would see the same car highlighted in others. So if I apply a filter in one view, that filter would apply in all of the other views. And so dashboards are one example of multiple views. It's actually been not very well treated by the academic community, right? Like we've been ignoring dashboards for many years and really only started publishing and researching dashboards in the last maybe 5 years. And so dashboards are these super, super common things that you've all seen many times, I'm sure. Like you've probably all seen COVID dashboards, for example, or you've all heard about dashboards that are being used in industry to kind of like show the CEO how the things are going and quickly make decisions and monitor the state of things and so on. And so the idea behind dashboards is that we have multiple views for data-driven decision-making. They're like a visual display of data used to monitor conditions and or facilitate understanding. And so here would be like a traditional dashboard for like a sales goal in 2016. We would have like a sales trend overview where we have like a goal line, which is something that is fairly characteristic about dashboards, is that we have certain kind of like goals that are specified. So for example, in COVID, we have certain rules baked into dashboards. For example, if we are under in green transmission phase, there's no mask required, or as a company, we want to sell at least 10,000 units next quarter, and so on. And then we have like different views that show us this, right? So here, for example, this would be cumulative sales, and this would be sales by month. And then very often we also have some kind of like numbers shown in here, right? Here's our goal of making 2.5 million in hardware software sales, but so far we only have 1.29, and we show this here in this gauge that visualizes that. And so these kind of like combination of key performance indicators and like data visualizations that are easy to grasp, easy to digest, is like a characteristic of a dashboard. And so this paper here kind of summarizes this dashboard very nicely. And so this is like mandatory reading for all the grad students in here. You should be taking a look at this paper before the next test. It's basically going into depth on these different types of dashboards and what they're good for. From this paper here, there's these 4 categorizations that they made. Here's like a strategic dashboard, which is roughly what I showed just earlier, right? Like I want to get an overview of how my company is performing, how good we are on sales, but it's strategic, it's not tactical, right? It's kind of like overall seeing where things are, and like it doesn't necessarily tell us where we should tune a knob to increase our sales, right? On the other hand, we have tactical dashboards. So tactical dashboards, in this case here, this is an example of a student's performance in a class, and the student could identify, hey, I'm kind of falling behind on these aspects of the class, and so I really need to study up for the next exam. So it's kind of actionable, and that makes it a tactical dashboard. Then there's operational dashboards, and here like lots of gauges on this screen here that basically just tells you what are current metrics, but it's not necessarily like tactical. It's just a summary of everything that is going on. It's a little bit like a monitor room of a nuclear power plant in a sense. And then there's social dashboards, and I'm sure many of you are using these. Like if you use any kinds of quantified self, any kind of like fitness tracker or something like that, or step count tracker. This is probably this looks like the Garmin interface, right? So if you have a Garmin watch, you might have seen this one here before. That's kind of like more social media. It might be kind of like tactical in a sense. You might kind of choose to change your training based on this, but mostly it's really for your, enjoyment. And so the dashboard design elements are key performance indicators that are often shown as numbers. And so like as we had there before, here are like, this is what we currently sold, this is our goal, right? Or they're shown in some simple visualization like a gauge or like a donut chart or something like that. And these gauges, they show like a numerical value and this context and reference point. So that it kind of like defines what is the goal, are we in something like the danger zone, or what is the minimum that we kind of like can have on a particular value. And we've all seen these COVID dashboards. This is the Utah dashboard. This is actually the first time today that I visited that this was mostly, oops, I wanted to click the other link. This was mostly green, right? Because like, obviously I haven't been looking at it since it's been fairly quiet around COVID, right? But so this is like a classical dashboard. We have like a mix of numbers here at the top, then we have a map, we have a table that shows you us values, and then we have additional visualizations here that are kind of like composed and that show us certain metrics, right? And this is, by the way, this is like many dashboards are single page, but this here is like a scrollable dashboard, right? Kind of like probably because of the complexity of the data and the richness of the data, they decided that this wouldn't work out in a single dashboard. And these dashboards are not super, like I can zoom in here, but they're not linked, right? Notice that I zoomed in here, but none of the other views here reacted to it. So this isn't really like a well implemented, well-designed dashboard. And so back at the beginning of the pandemic, when all kinds of states started publishing these dashboards, like a PhD student in our lab, Daria, she analyzed all, like for every single US state, she looked up how do they report COVID numbers, and she did like a preliminary analysis of all of these COVID dashboards. And so if you're interested in that, take a look at this blog post. And she was actually also grading them. So there's like, a few got an A or an A+, but like there were quite a few bad ones. Okay. This is probably the most practical advice that you'll get in this lecture if you're like a business analyst or a business person. Here are certain tools that you can use. Like dashboards are kind of tricky to, well, they're not hard to build, but it's a lot of work to build them, right? And so you typically wouldn't use D3 to build a dashboard from scratch, but rather you would use a dashboarding tool. Of course, you could be like an engineer for any of these companies helping them build dashboarding tools. And so some of these dashboarding tools that are like widely used in business are Microsoft Power BI and Tableau. Microsoft Power BI is essentially like a Excel version on steroids, right? Where you have lots of different charts. And Tableau is kind of like the biggest data visualization company out there. They've recently been acquired by Salesforce, and they're like headquartered in Seattle. They also do a lot of visualization research. So the paper about dashboards that I earlier showed is actually by people from Tableau Research. And so they're really good at dashboards and at like data visualization for business use cases. And then many of the COVID dashboards that you see are done with Plotly. Plotly is this kind of like low-code environment where you need to do a little bit of scripting, and then you can throw together something fairly sophisticated, complicated, and put it on a website. So Plotly is kind of like, for example, if I had to do like a dashboard for the state or something like that, I might be using Plotly. And then there's also Data Wrapper, which isn't really like a dashboarding tool, but it is a kind of a tool that a lot of journalists use to kind of like embed visualizations with the story, and they're really good at the aesthetics of it, right? They let you customize everything, and so they're like a really cool platform. And so these are just some examples. There's others out there, but these are kind of, I think, the big players right now in the commercial dashboarding world. Plotly is mostly free. There's like some enterprise features. Power BI and Tableau are to pay for, and Data Wrapper, like you can do free demos, but you also have to pay for it. So I want to distinguish now a little bit between dashboards and analytical multiple view systems, or MVs. And so the idea of dashboards is really that you give somebody who isn't super engaged with the data a quick glance, right? So you as like a concerned citizens might want to look at a COVID dashboard to make a decision about whether you're comfortable going out to a restaurant without a mask, or your CEO who has supposedly only a minute they get to look at this dashboard and see whether everything is on track or whether they have to steer in some different directions. And the exact opposite are analytical multiple view systems. And so these systems kind of like give you an insight into a data set or into multiple connected data sets with multiple different views in extremely, like in a lot of detail. And so typically for these kinds of systems, you have to choose your own view composition. So you might start out with a blank canvas, right? And you decide, I want to see this data set and a scatter plot and put it here. Then I want to see here a line chart with this data set, put it here. Those all should be linked, right? So this kind of like setting it up completely on your own without like a story or without any of these pre-baked key performance indicators. That would be your like an analytical multiple view system. You would also have custom filters, and these systems typically connect between different views very well. And this has been kind of like, you know, what visualization research has focused on a lot, because that is what scientists who we often work with are using. And so here, like the picture I'm showing here is from this company that I co-founded a while ago. And this is like an analytical multiple view system that pharmaceutical companies use to evaluate potential drug candidates, right? So they look at first at cell lines and what are the genomic profiles of the cell lines, what is the gene expression, the copy number, then they look at compounds. They might look up the compounds on our website that you see here at the bottom, or they might see some kind of like, you know, drug response values, some curves, and so on. And it's completely like open-ended exploration, right? The analyst can like has a lot of degrees of freedom, and it's all fairly complicated. So you kind of like, it's not for like the casual user, but it's more for the expert user. Okay, now I want to kind of like, after this rough overview of what these things are doing, I want to dig into a little bit. Let's do a little bit of a systematic analysis of these, both these more complicated multiple view systems and dashboards. So the first thing that we have to ask ourselves, do my multiple views have a shared encoding? So are all of them bar charts or all of them line charts, for example? Or do they have shared data? Or is all the data shared, or is only a subset of the data shared, right? Or do they have shared navigation? So for example, if I have a time series data set and I zoom into one region, are all views responding to that? So these are kind of the questions, and this is kind of like the figure and the classification that we have in our textbook here. So shared encoding, is it same or different? Shared data, is it all or subset or none? Or shared navigation? And then we have essentially down here, we have this matrix of data and encoding. So if we have the same data that is completely shared and the same encoding, then it's kind of useless, right? Then we're just showing the same view twice. But if we have the same data and a different encoding, then this is called multiform visualization, and we're showing the same data set with two different visualization techniques that might reveal different things. If we show a subset of the data with the same encoding, it would be like an overview in detail. If we show the subset of the data with a different encoding, it would be what's called multiform overview in detail. And if we have the no shared data, but the same encoding, then we would have small multiples. And then again, if we have here, this wouldn't be linked views. If we had no shared data and different encodings, then it would just be two different data sets that are being visualized next to each other. So I'll dig into this in more detail over the next couple of slides, but this is like a good overview here. So when we link two views, we have the first option here is, what do we want to link? Is it the highlighting or maybe the filtering? Do we want to link that or not? Or is it the navigation? Do we want to link that, to share that or not? And if it's, then we also have the question is, do we choose the same encoding or a multiform encoding? Or again, the data set, do we share all, a subset, or none of them? And so here would be like a simple example in MATLAB actually for linked brushing, right? So we've seen something like this before, but this is like an older example where you select some points here on a map, and then there you have two different dimensions of a data set. So this would be kind of like some of the same data set, but not all of the same data set, right? So it would be partially shared data, but you see the linking between them. And here's like a more complicated example. This is also like a tool that is kind of like now a commercial tool came out of the Viz community that gives you these dashboards. And so here I can hover. This is like 8 workers. Where are 8 workers kind of like in danger? What is happening to 8 workers if they're, for example, going into a war zone or something like this? And if you hover on over any of these elements, I'll click this here. If you hover over any of these elements, you see the corresponding elements highlight in all other views, right? Like notice that if I, for example, if I highlight here something, like these views here all change, and these views here also change. And then if I click it, it actually filters it, right? So this is like a very shared one, and I can also here choose this dynamically, what kind of views I want to have, and I can do things like make it smaller and do things like filters, right? So this would be like a fairly complicated, kind of like somewhere between a classical dashboard and like an actual exploration interface. So the next thing I want to talk about is multi-form views. And so this is when we use different visual encodings between the views. So this implies that we have some shared data or even all shared data, because otherwise it wouldn't make all that much sense. And if we do this with a subset of data, this could be useful for overview and detail, right? So we have some visual encoding that shows us an overview in some kind of like with a certain visualization technique, and then we have a detailed view that shows us with another visualization technique more about the data. And so the rationale for using this is that a single monolithic view has strong limits on the number of attributes that can be shown simultaneously. And so if we use multi-form views, we can show more of that. And then different views support different tasks. And so here is like this was a homework from a couple of years ago when we had the election between Barack Obama and Mitt Romney. This is kind of like, it's kind of a dashboard, but it is kind of a multi-form visualization. So for example, the two views that we have here up on top here and down here, essentially if we just talk about the vote share, then they kind of have to show the same data, right? So these are different encodings that show a different aspect of the data. The one here on the top shows us kind of like a stacked bar chart with this note here where's the threshold to win. And the map here at the bottom gives us the context of where are these states, right? And what, like, are there any geographical patterns? And so they show kind of the same data. Of course, one shows us something more about the geography. The other one shows us about the sum, which isn't really kind of like in the data set itself, but they show us completely different things, right? Even though they show us the same data. So that can make a lot of sense to have these different perspectives for the same data, because it really tells you something completely different. And this is like an early example of, we'll talk about these kinds of visualization techniques in the network lecture, but essentially in networks, there's two different visualization techniques that are predominant. These are node link diagrams, which is what we have here on the side. And then there are adjacency matrix, which is what we have here. And both have strengths and weaknesses. And so these guys just thought like, okay, let's just combine both of them. Or here's another example from a work that my group did a while ago. This was about path search in networks. So like, what are the possible connections between two nodes in a network? And so we had two different visualizations. We had one that just listed these paths and all possible paths essentially. And then we had one that shows us the topology here, right? That gives us a sense of what are these paths in the whole network. There's like a larger network here in the backend. And so they have very different properties, right? So here I get a good sense of what are the important nodes, right? So for example, this is a co-author network from like Hans-Peter Pfister to Ben Schneiderman. Ben Schneiderman is the mantra guy, and Hans-Peter Pfister was my postdoc advisor. And so you can see that they are not directly connected, but they're really like connected via this one person, right? So this person here has directly worked with Ben Schneiderman, but they've also like had multiple students or collaborators that have worked with him, right? So we see that this person has like a very high centrality in this network. Whereas here, we very quickly see, oh, there's 3 paths of length 4, right? That's not something that we immediately saw in the other one. And we also have, because we have this linear layout, we have space to show additional attributes about those people, right? Are they, like how much have they published? What are their citation metrics and so on? So different, like same data, just different visualizations that give you very different, that allow you to answer very different questions about the data that you have. Okay, now I want to move on to design critique. And of course, today we have to do a dashboard. The most prominent COVID dashboard of them all, the Johns Hopkins COVID-19 dashboard. I noticed that the printout here isn't great because it's all black. Maybe something that is already a problem with this visualization, but you get the idea. I'll leave this up. And there's a couple of specific questions in addition to the standard critique questions. I also want you to talk a little bit about the shared encoding, shared data, Euler subset, shared navigation. And we'll do this for 15 minutes, and so we'll continue on, at 2:45 with kind of a discussion. Yeah. Sure. Yes. There might be still some more over there. Any leftovers? Thank you. Anybody still need one? Okay. Yep.
Like if this was like on a test or something, would you say, okay, the middle graph is here,
Exactly.
this is
I would break it apart if you were to ask about marks and channels, right? Then go for this graph, and then like actually these are the only two graphs, right? So
Oh, and another question on that.
Sure.
Does like text or stuff count as a mark?
Yeah.
Channel?
Yeah, this is like a symbolic encoding.
Okay.
Yeah. So I would say this is like, what's the symbol is the channel, and the just the presence of the shape is the mark.
Okay. Cool. Thank you.
Mhm. Okay, so let's talk a little bit about this visualization. So who wants to tell me about what is the data that we're seeing here in this visualization? Please.
It's the local case data. And then
Exactly. So we have cases and death data here on a global scale, including locations. Anything else that I'm missing here? I think that's pretty much it, right? It's on a different level of granularity, maybe that we can add that, right? There's some country level data and some state level data for states. Yes, this is when I took that screenshot. Okay, what's that? Recoveries? Oh yeah, that's true. We also have recoveries in the green font here. Great, so let's talk about the map first. What are the marks and channels that are being used in here? We have circles, so that would be area, and that's the mark. And what's the channel? Size, okay. So anybody can see something wrong with this map? Or everybody likes it? Is this super informative? Exactly. So it gets very, very cluttered, right? Other ideas? Exactly. That was actually one of my big complaints about this chart. If you look very closely here, the US seems to be reporting this on the county level, right? There's like a bubble for each county, not even for the state, but for the county. Canada does it statewide. So it basically looks like there is no COVID in Canada. And if there is COVID in Canada, it's only up north, which is clearly wrong, right? So they just use the geographic center. And so, yeah, the problem here is that different levels of aggregation, in addition to this, the cluttering problem, so that also makes it really bad. I checked just now. If you go to the website now, they fixed that between Canada and the US, right? They're now doing for the US, they're also doing state level. Yeah. So yes, what I would do in this case, I would, they also have like a a version for the US that you can go to. So if I had a global map, I might just do state level data or even just one dot for the whole US, right? But if you have US level data, I can break it down as far as I want, right? So I can't use completely different aggregation levels between different entities on the map. That is definitely a problem. Another thing, why do you think, like, why the eastern seaboard here looks extremely hard hit by COVID, right? Consistently. Also Western Europe compared to, let's say, Africa, or maybe the better question would be China, like very densely populated areas in China. Like, you know, what's going on here? Why is this data like that, or why is it shown like that? There's multiple things going on. Yeah. Yeah. That's definitely one issue. Exactly. So like states, countries have certain agendas, right? China might underreport cases. Countries may have completely different methods of what is a case, what counts as a case. Countries might have completely different like density of measuring cases, right? Of testing for cases, right? So this is all extremely difficult. I saw a hand, like, yeah. I have a little bit of a hard time hearing you. Yeah. So there's like perverse incentives for reporting that kind of data as well. Like some hospitals want to over-report maybe because they want to make clear that they need more funding or something like that. But one thing that is generally true for all of these kinds of representations, not specific to COVID, is these maps are dense where people live. And they're very sparse where people don't live, right? So we don't act like, you know, mostly what we're seeing here is a map of where do people live, with some caveats about, like, you know, political situations and how they're being reported. And that is generally a big problem with these kinds of maps, right? Because like in the US, like any election map, and we'll talk about this in the map, if you have like the Midwestern states, including Utah, right? It's very sparsely populated, and then you have other states that are very densely populated, and then it looks like those kind of states are not affected, or they don't, or they vote for them on like there's a very strong majority for a certain party and so on. So that's a big problem with these kinds of map representations. Okay, so I guess the only other visualization we have here is this kind of like line chart that probably dots. And then the rest of this is here are mostly numerical values. So let's talk a little bit about these numerical values here. Anybody have an opinion on those? Yes. So color problem, we have red for cases instead of death, and green for recovered, and death is shown in white. Any other problems that you have with these numbers? There's way too many of them, correct?
Are these like raw numbers versus like per million?
That's a very good point. So this is like a big gripe I have with this chart here. These are actually raw counts, right? And it doesn't normalize per population. And so look at the top countries here: US, Brazil, India. These are some of the biggest countries in the world, right, by population, right? So it's not surprising that they end up on top. So you should really do something adjusted for population here. That would be a much better chart here. One thing that really bugs me about this dashboard, particularly, maybe anybody has another idea before I say that? You know, do you really believe that on July 6th at 9:34 a.m., right, at that moment, there were exactly 11,495,412 cases? It's, you know, it's just like, you know, I think that using that kind of precision in a chart like that is just stupid, right? Like, why would you do that? You want, like, you have a rough guess There's so many things that go wrong with the data collection here. If it's collected by so many different countries, there's delays, there's hiccups, there's holidays, there's corrections. Why would you go in and give a number like that, right? That just projects a false certainty. Sure, but why don't you say about 11.5 million cases, right? The problem I have with that is that if you, and generally, like if you communicate something with this level of precision, but your data is so incredibly noisy, you're mismatching like your encoding, right, with what the data actually is, right? So like, that you could, to their credit, they say total confirmed. They don't say cases, right? Because that would be even harder. But even then, it is extremely noisy. And these super precise numbers give us the sense that we have a perfect handle on all of this, right? Yeah.
There's also like a little number like 100 data.
Yes.
What is the purpose of that?
I agree. It is very odd. There's some like odd choices in here, and also like about color, right? As you can see on your printout, this isn't a particularly good choice in terms of contrast, right? It works on a screen. It works fairly well, I guess, up here, but it doesn't work good on a printout. And if you create a visualization that millions of people are using, you should also think about these kinds of accessibility issues. And so, the current version isn't much different. It has more super precise numbers. But it's kind of like they fixed the issue with the states, right, a little bit, and they have a few more charts, weekly cases, weekly death, and so on. And they moved to a 28-day rate, but they also don't adjust it by per population or anything like that, right? So they've made a little bit of progress in the last 2 years here, but they haven't done much better. Okay, but let's go back to this one and talk about the next few things. So in terms of multiple views, do we have any shared encoding here? So, there's like a lot of tables here that is kind of like, the same format, but it's also not the same data. So I wouldn't really call it shared encoding. You could maybe argue that this part here, the sum of this table here makes up this part here. So we have a shared encoding and the shared data, but a different level of aggregation. What about shared data? Yes, so we have the data that is in here, also in the map, right? This is a classical multiform, right? We're showing this the same data in 2 different forms. The one is really focused on like the sorted list here, giving you what are the biggest, what are the countries where there's the most cases. The map gives you the geospatial context, right? So completely different perspectives, classical multiform. And then shared navigation, like, well, you got to print out. So and it's also not particularly interactive, right? So I would say probably not. Great. So I guess we talked a little bit about the fair depiction already. That if I were, for example, to click on the United States, that I would zoom into the map, and I would get here, instead of a list of countries, I would get a list of states, right? So that I'm kind of filtering down both simultaneously. Or if I click on, let's say, Europe, that I would get the data about Europe. Yeah. Exactly. Yeah, so yeah, depending on how you think about it, you could think about this as shared navigation. It's a different dashboard in this case, right? That's giving you a different visualization. Well, okay, well. So this dashboard was actually, well, is there anything missing or anything that you would I guess at that point in time, like nowadays, we probably would add vaccination data and so on. But at that point in time, is there anything missing in this depiction here? Yeah. Other opinions? You know, that's a good question for the development team there. I'm pretty sure this is. I'm guessing they did this fairly quickly, right? But it's still there today. So it shows you different perspectives, I guess. It's province, state dependency, death, cases by, okay, country, province, or US. So yeah, if you play with it, you can find out. But I find it amazing that 2 years later and millions of visitors, probably every week, this is still there. So the one big thing that I really think is a problem here is that it doesn't give us population background, right? Like that is a big problem. Also, it doesn't show us any change. Like, is this a hotspot or not? Is it what's going on? That's a big problem. Yeah. Yeah. Mm. Yes, exactly. So that's an important relationship, right? That isn't shown here. Yeah, you could switch between. Yes, they probably have that even. You can switch between different maps down there. Looks like it's. So another thing, what is bigger, Greenland or Africa? That's kind of like a little preview of the Maps lecture too, right? They're using Google Maps here. Also, you know, the most prominent labels on this map about COVID is North Pacific Ocean, North Atlantic Ocean. That's not really relevant, right? So, you know, kind of a wrong choice of a map here as well. Any other comments? Yeah, exactly. So, you know, the nuance. And if you think about this, in this, we had the strategic, the tactical, operational, and social dashboards. Which of those 4 categories is this? Okay, would anybody change their behavior by seeing this here? Like if you look at this map today, at this one for today, would you imagine changing your behavior? Would it be tactical? No, right? Like nobody would. This wouldn't be sufficient for me to change my behavior. So it's clearly not tactical. It's also not very, well, maybe it's operational, right? It's kind of like some facts that are thrown in without context. So that could be kind of like operational. It's clearly not social. And so it could be either operational or strategic, right? So if I, as a country, want to, or as the CDC, want to make any decisions, I could use a dashboard like this. It says weekly doses administered, and I would be very skeptical that we suddenly hit peak vaccination yesterday. So yeah, I don't know. This is an artifact, right? So something that I would probably guess is that it's a mistake in the data. Yes. Exactly. So, you know, all of these problems are manifest still in this latest version. So back when I took the screenshot here, I did write a blog post about this. like why dashboard, the case against dashboards for visualizing a pandemic is what I called it. And the argument that I'm making here is really like these dashboards with this kind of over precise like view that give us a sense of certainty that we have this under control, but they don't give us any actionable evidence, and they don't give us all of the context and the nuance. And so like a counterexample of how to do this well is our World in Data website. Like some of you might have seen that, right? And they have a data explorer that is kind of like a little bit tricky to use, as Max has found out. But they also have these in-depth articles, right, where they talk about, here is the nuance of the data. Here is like, this was like a visualization that I really liked at the beginning of the pandemic, right? That gives you like cases, how have they doubled, what is new, the death. You could sort that, you could adjust that. But they also had these kind of like detailed reports where they like, talk about the failures of data collection and so on. And so if you want to inform the public about something important like COVID, you might take a more nuanced approach where you mix text. It's kind of a weird day today for technical stuff. Where you mix text explanations, right, and then visualizations. You might, I would probably use a tool like Data Wrapper, and to do like a New York Times style approach where you have like, here's an introductory paragraph, here's what this data means, then show the data, then explain the caveats, right? Bring it all into context, normalize it by population, and so on. Let experts talk about it and show data in context. But don't do this, throw up a dashboard and everybody can look at these seemingly precise numbers. Okay, any other last comments before we move on? Great. So the next thing I wanted to talk about is overview plus detail. So overview plus detail is when one view, when one view shows an summarized information about an entire data set, while additional views show more detailed information about the subset of the data. So for example, in the COVID dashboard we just looked at, the map shows the overview, right? It shows the data for all countries. And then on the left, we had the biggest countries, or the countries with the most cases. So that was a detailed view of that. And so the rationale here is that for large or complex data, a single view of the entire data set cannot capture fine details. So we couldn't read like the details from an overview, but we can read them if we actually ask to receive the details dynamically. And so you can apply this to any kind of visualization technique, but here's like a nice video that shows this for time series data. So what they do here is they have a line chart here at the top, and they have the green region here that is shown in more detail down here, and then they have the gray region, which is shown in more detail down here. And then they could even add, they can add multiple stocks. This is stock data here. And if they're not interested in a particular region, you can remove it. And so here is like another use case where they do 3 splits. So you have one zoom in here on Black Monday, and then you can create another zoom in that looks at a specific period, right? And so you have now like multiple levels of detail. First, the global overview, then 2 views, like a more detailed view, and then very on a daily level down here. Or that could also be like more abstract, right? Here, this is a tool that Mariah Meyer, a former colleague at Utah, developed, where she has kind of this multi-form overview in detail. And I'll
MISBE is a multi-scale Symfony browser for comparative genomics data. It is the first Symfony browser side-by-side views of the data scale. The genome view showing all of its chromosomes, the chromosome view showing all of its blocks, and the block view showing all of its insertions. MISBE incorporates a variety of visual cues and interaction.
So here you have the overview, and then here are some detailed views.
The high-level genome view shows the circular overview of all source chromosomes in the entire range, with the destination chromosomes on the right. Selecting the source chromosome highlights it in black, and a copy of it also appears. We encode this intended relationship in the connection with these line curves into the matched block colored by the destination chromosome using repeating 8 color map. The colors also provide an overview of all block destinations with outer source genome ring. We can look through the source chromosomes with left and right arrows or using mouse click. Our version of edge bundling is based on block contiguity and destination chromosome, making the location of the spurious block more obvious. Changing the curve transparency makes the stronger connection stand out. We move the two triangles to filter the block in this view and in the chromosome view.
So there we see linked views, as you notice maybe on the right.
Selecting the chromosome updates the chromosome view in the middle.
So in the chromosome view here would be kind of, this is a classical example. Here we have an overview, right? This is the overview in the context of something else, and then we have much more detail here, and then we have even more detail here, right? So that's a like a more complicated example of something like this. And this is a tool that we did. So here we have overview plus detail. This is a clustered heat map of cancer data. And so you have 4 different clusters here on the left. And kind of like, you see a rough overview of what's going on here. But if you want to inspect one of these clusters in more detail, you can pull it out and see those details. And then you could even, like here, we are actually showing the same data, but in this case, overlaid on these metabolic or signaling network in this case. So that's kind of like the same data shown in a different context, like a subset of the same data shown in a different context. This is another example of like a multiform relationship. One super important thing is small multiples, where we use each view with the same visual encoding, but show different subsets of a data. So for example, we could show, like in a temporal data set, we could show in one view 2020, one view 2021, one view 2022, right? And show the same data, and then we can kind of easily compare between the years here. So the rationale is quickly comparing different parts of a data set, relying on eyes instead of memory. And so like here's an example of that. If we look closely here, this is all of the same network. It's again some metabolic network with different experimental data overlaid, right? And so this actually here we have 7 times 1, 2, 3, 4, 5, 6, 7 times the same graph, but different data overlaid. So this is like a classical multiple view paradigm. And what's also often common is with these multiple coordinate with these small multiples is that you have one view that you can select that is shown bigger, right? Because the small multiples tend to be, as their name indicates, small. And so if you want to look a little bit more closely, very often people choose to dynamically reveal one of these views in more detail. And this is kind of like the similar thing that we did in the Stratamax technique. Back here, we have an overview of different like small multiples here, and then you can have one detailed view pop out here. Okay, so partitioning is kind of like related to the small multiples, but partitioning is also more general and a super powerful technique. So partitioning is about splitting a data set into groups. If you're like thinking in programming terms, it would be some group by, right? And you have a lot of design choices if you group by. You can choose how to divide data up between views. For example, giving a hierarchy of attribute, you can choose the splits and the order of splits, and you can also choose how many views you have. And typically, something like this is data driven. And the attributes that you split by, that you group by, are typically categorical, but you could also take some numerical vector and bin it, right, and then create categories from it, and group by that. And so the data here is kind of grouped. Like what we see here is age distribution by state. And so we have in California, we have like the color scale here tells us orange are the seniors, 65 and older, and then the kids are blue. And we see kind of like 4 different states: California, New York, Florida, Texas, or whatever. What is TK? Texas? TK would be weird right, for Texas, but anyways, doesn't matter. So in the one case, it kind of like groups this here, like globally, and in the other case here, we're faceting twice. Like here we're grouping only by state, and here we're grouping also by age, right? And so kind of like this makes it easier to compare the age groups within a particular, like between the different states, and this gives you like a more like a global sense of what's going on in total, right? So the partitioning here really like the different partitions, same visual encoding, just different partitions give you like allow completely different tasks here. And here is our famous IRIS data set. If you've ever taken a machine learning course, you've seen this before, right? I could like separate, like I could just color code them, but whenever I color code, I can also separate out the views, right? And that's very often if you have cluttered views, that is actually a very powerful technique to do that, because then you can kind of like really see what are the categories individually without worrying too much about overplotting. A very cool technique is trellis plots, and that takes this kind of grouping a little bit to the max. And so trellis plots has these kind of like ideas of panels and partitions, and then also does some main and Frick ordering. So the panels are attributes encoded in individual views, and the partitioning attributes assigned to columns and rows. So here we're partitioning by year. This is like barley yields, which is another famous machine learning data set, barley yields in 31 and 32 in certain farms, and then with certain seeds, right? And you like essentially for each of these strain types, you see the yield in these little dot plots. And so we can kind of can compare both within that year. It looks like this farm here did particularly well, but also that these certain seed types did, like this for the top one here and the third one here did pretty well. Other farms didn't do quite as well. And in 1932, that wasn't quite like, it still looks like this farm here, or this farm here was the best, had the highest yield, but it's not quite as a big outlier compared to the rest, right? And so we have these different ways of slicing and dicing this, and we can actually also choose. Well, this is just a recap of what I just said, but we can also choose to, instead of faceting, we can choose to superimpose, right? So here on the right, we facet by year. On the left, we superimpose by year. So here it would be 1932 and 1931. And you can see, like here, this actually works pretty well, right? Because I have those two charts, except for the light blue, which is maybe the best choice. You can do this comparison maybe a little bit more effectively than in the chart on the right. But if you had, say, 4 or 5 of them, it would be tricky to do. So you might actually choose the other one. Yep. Yes. So in this side here, it's the year. In this here, it is the farm. Yes. So you know, in this case, the orange, the green. Yes, exactly. The green one is the orange one in this case. And you could also do this with a spatial layout. So with recursive subdivision. So for example, here, this is like a tree map, and we'll be talking about this when we talk about graph and tree visualization. But here the partition is like to flexibly transform data attributes into a hierarchy. So for example, if I have the stock market, right, I could first divide it up by companies, by sector, and then I could divide it up by companies that are profitable versus not profitable. Or I could divide it up by companies into bins based on their market valuation or market cap or anything like that. And there's like this very cool dynamic technique that creates these tree maps flexibly with like even like a little built-in programming languages. So what we're looking at here is London properties. And the first partitioning type here, is it the house type? So is it a flat? Is it a semi-detached house, or is it a terraced house? Then the next one is the neighborhood. So you can't see this very clearly, but there's labels here for the neighborhoods in here. And the third one is the sale time. So within these, it's also ordered temporally. And then we have encoding attributes that are the average price in color and the number of sales, this is the size. And so what we can then see is between neighborhoods, we have different housing distribution, and within neighborhoods, we have similar prices. It's kind of like what we can learn from this. And if we take the same data and just slice it differently, so here, for example, we partition first by neighborhood, then by house type, then by sale type, a year, and then by sale time month, right? Then we get a completely different picture. Same data, same visualization technique, just different choice of partition. And what we here see, like we also encode here the approximate neighborhood location, so that city center districts are in the center of the chart. And so what we can see is that expensive neighborhoods tend to be near the center of the city, but there's also some expensive neighborhoods out there, right? And so I'll show this quick video here. So I guess you get the idea. What I found very impressive was I saw this talk in person, and the speaker typed in all of this code that you see at the bottom here live on the podium to dynamically create those maps, right? That was a very impressive demo. Okay, the last thing I want to talk about is layering, right? So I talked about this a little bit already. We can have multiple views that are in separate spaces, but we can also have multiple views that are on top of each other. So we can create multiple layers. And they could be simple, like if we use the same visual encoding, what we basically have is just like a scatter plot with two different dots, right? But it could also be more complicated. So the simple case here are line charts, right? We layer multiple data points on top of each other because line charts do that pretty well. But also that has limits, tends to clutter at some point if we have too many of them. But we can also use different visualization techniques to layer on top of each other. So here's a combination of a line chart and a bar chart. And that can make sense in some cases, right? You have to be careful about it, but it does make sense sometimes. But like, you know, fiddling with dual axis and just layering on top of each other allows you, and adjusting your kind of axis allows you to do crazy things, like find these spurious correlations, like number of people who drowned by falling into a pool correlates with films Nicolas Cage appeared in, right? Probably not a causal relationship. Clearly, like you need to be careful about these kinds of things. And then we can also do a combination here. So this here is a multiple view layout where we have a hierarchy of certain things, and then another grouping here. And so what's cool about this is that first this is faceted and we have small multiples, but then down here we also have layering, right? And that is kind of like the same data that's shown in this whole column is now shown in this one chart, right? And so these support different things, and it's kind of like a neat way to visualize this. So you can like flexibly combine this. And then finally, I'll just post this video to the Slack. We're a little bit over time, but this is the last slide. So thanks, everybody. Next week, we'll be talking about Tableau datasets, 2 lectures of that. See you then.